Wow. My gosh, this is quite an audience. Last year was incredible, and I'm so happy to be back. Thank you all for having me. Thank you all for coming to Console.loggers Anonymous, the support group for many of us who, I guess up until now, this is our primary mode of interaction with our terminals, with our command line applications, with our node servers, with our web applications. This is going to be a bit of a debugging roadmap from local to production, and we're going to be learning about resources, practices, tools that we can use to speed up local development and, critically, resolving production applications if they happen, if any of us in the audience maybe write imperfect code from time to time. So a bit about me. I am director of platform at Tenkai. We are a company that publishes and distributes manga, Japanese comics, in the West. You might have seen our logos on the spines of your books if anyone here reads manga. We've got Denpa for run-of-the-mill, classic, all ages, good times. We've got Kuma for our boy-on-boy, spicy comics. And we've got Faku for when you put on a scented candle and you dim the lights. Maybe your partner's out of town and you need... Anyway, so I'm also the lead maintainer of Starship, which is a beautiful, blazing fast, cross-platform, cross-shell prompt. If you ever see people with a cool little symbols in their terminal, that's Starship. I highly encourage you check it out. It is one of the most critical pieces of my day-to-day workflow, and I hope it can be for you. But here, the star of the show is the humble Console.log. For many of us, it might be the first line of code we've written. Hello, JSHeroes. And it continues to be kind of the most important tool in our toolkits. It allows us to really elegantly, easily inspect how our code is operating. We can get some insight just at a glance how things are working. And oftentimes, it's our primary tool when we're debugging to really, who's done this, right? To know where things are happening and if things are not. But regrettably, it's not always the best tool for the job. As we gradually just add more and more things to our log output, especially in a node application, it starts to pile on and it becomes what was once useful and valuable, it becomes a little overwhelming. In a production application, when we've got hundreds, thousands, millions of users hitting it, it can be overwhelming and it becomes difficult to actually know what's happening. But let's bring it down in scope and look at our local development habits. Every added log becomes an eventual burden to our future selves. And without them, we have no insight into how things are going wrong. So we can't get rid of them, but we can't live without it. Our usual flow is kind of this. You run the server in a node application, you encounter the issue, so you hit the endpoint, you add more logs, and you start from scratch. You have to hit the same endpoint, and you just keep repeating that process, and it's frustrating. Maybe you added a log for an object, but it didn't drill down deep enough, or you need to expand a value in an array. And this process is just kind of frustrating. Even with a watcher, you have to reproduce the error over and over and restart your server. So we're going to talk a bit first about, in local development, the JavaScript debugger. It was briefly touched on earlier by Nicolo, who was demonstrating how it can be used with source maps. But here we're going to dive a little deeper into how we can peer into the inner workings of our application. So in an example here, we've got this function. We receive a cart. It's got a number of items. And we iterate through the items and add up the prices. And what the debugger allows us to do is basically halt execution and just put pause on what's happening. We sit on a particular line of code. So in this case, for instance, in this case, we're highlighting a particular line of code that's the currently executed line of code. And given we're in this location, we can see exactly what's happening. So you can introspect into the current variables in our local scope. We can see what the value of I is, so we can see we're on a zero-based system, the second iteration of this loop, and we can see that the total right now is 1.5. So that's the essence of the debugger. Now, to see it in action, it looks a little bit like this. If you use VS Code, this is maybe familiar to you. but this same interface can be used in any other editor, right? Or any one that has debugger support. So it looks like this. We've got our run and debug pane hanging out on the left. And when the debugger is going to be used, you add a breakpoint. This kind of section beside the line numbers is called the gutter. So you click on the gutter on the line that you want to stop on. And then when the debugger kicks in, we get this bright yellow highlight over a particular line of code. And that is the line of code we're on right now. This is maybe where you would usually put a console.log statement, like just under that line of code to see what a value might be. But importantly, we can actually see the values in execution on the top left with our variables. So this is critically, this is so valuable. This gives us so much insight into how our code is executing, and you don't have to add log statements for every one of these. So let's crack that open. Let's see what is in cart. It's 3 items, and they're the same 3 items that were instantiated above in the cart array. So the next critical piece of the debugger is these icons up here, and that's kind of like the toolbar to control the progression of your code execution. So we're going to look at the most important buttons here. You got step over, step into, and step out of. The step over kind of works like it's described. Given we're on this particular line of code, we're about to execute calculate total price. The yellow highlight is what line we're about to execute. And when you click on that button, it brings us to the next line of code. And it steps over, it executes the function, and total price has been defined. If we were, for instance, to hit step in, we'd be able to look at the internals of the function. And this is an amazing way to learn how libraries we depend on work internally, their inner workings. It exposes the inner functionality, and we can step through the particular lines of that function. So if a dependency isn't behaving as expected, this is how you can uncover maybe internal bugs, and you can contribute a PR to fix it. Lastly, we have step out. So if you're in a function and you're tired, you kind of get what went wrong, you can step out of it and go back to what you were doing, and the function's been executed. So in practice, it looks a little like this. Let's say the debugger is actively running. We can now, on highlighting the calculate cart total line, we can step into the function, like so. And now it jumps us to the file of the relevant code. And we can see from here that total is not yet defined. And we can step through the lines here and step into the for loop. I has now been defined. It checks cart's length to make sure that I is less than it. And you can see now in the variable pane, I is 0, total is about to be defined, and total's been incremented, and so on. So you can see how this is critically useful. You can step through every particular line of code and see how it's accumulating the total value, the I value of this loop. Until finally we have a total of 4.5. We add 2 fixed to truncate this, what could be like 3s repeating, a long series of digits. And we can see here that the return value is 450 for this function as a string. So if we then progress through the execution of the code, you can see that something bad is maybe about to happen. Cart total is 450 as a string, delivery is a number, and total with delivery adds up to 451.3. And just like this, we can get some insight into why something horrible can happen. Final price is nan. This didn't involve having to rerun the function over and over and hitting the same endpoint over and over. We knew at execution time because we can peer into the inner workings of our function. So tremendously useful. And for a lot of people, this can replace our repeated use of Console.log. Now, how do we get this running? How did we get to this point where our editor is connected to our code? Well, VS Code has some phenomenal docs, but they are long. So we're going to step through the process ourselves. I'll show you a little bit of my workflow. Given an instance of the terminal and our editor, you start by running the node command as you typically would. You add the inspect flag, though. And what that's going to do is on your system, it's going to run a server. This is the debugger server that runs a WebSocket connection on port 9229, on unavailable port. This might change, but in this case, we can see it's on that port. And then you can hop over to VS Code. It's kind of similar on other editors, IntelliJ and so on. You go ahead and attach to a node process in the command pane on port 9229. And just like that, we're attached. Now our debugger is running in the editor. We could see the little debug toolbar at the top, right? And we can go ahead and do what we did last time and add our breakpoint. So this is an express server. When someone navigates to the home path, to /, it's going to trigger that breakpoint, and we'll be able to step through the lines of code. Like that. If someone hit that endpoint, then suddenly our variables pane has cracked open, and we can see the request object. So compared to Console.log, it might be a little longer, right? You have to restart the server. You have to attach the editor. You have to add a breakpoint, is what you might think. But we're going to shorten this list a bit. We're going to find ways to make this arguably easier than console logging. So in our package JSON, when you would usually just have a node script, there's no good reason that we can't always be running with inspect. Now, the inspect flag, well, let me say, debugging does take longer. It takes more CPU time whenever it's executing code, considerably more, but it only does it when your editor is attached to the node process that's running with inspect. So until you're attached, it functionally runs in the same way. I don't recommend this in production. This is another endpoint that you have to protect, another port that you have to protect. But in local development, just keep running the inspect flag. There's no good reason not to. And what this allows us to do is to reliably just be able to hook onto a running server. So with that, we don't have to restart the server with inspect if it's already running with inspect. Next, to attach the editor to our debug server easily, what we can do is make it so that inspect is always on the same port. So now it's fixed to 9229. When you're developing locally, you're always exposing your server usually on the same port, on like localhost 3000, so that you can just pop up in your browser and navigate to localhost 3000. Debugging should be the same. One application should have one port, and one application's debugger should have one port. So in that way, we can go ahead and configure our editor to just always attach to the same port, which makes it a ton easier. So we create a new launch config. We can use the node template. And we can remove some of what's already there. We're not going to be launching, we're going to be attaching. We can give it a nice descriptive name, attach to port 9229, and set a port to 9229. So with that in place, now the process of attaching your editor to your debug server is a matter of just hitting F5. So when we go back to our application, we add a breakpoint. You hit F5 for attach to debug server, and it looks like this. I hit F5, and it's running. It's already attached to my server, and when I hit the product endpoint, it pops open the pane again. We're debugging already. And here we can already start inspecting like the request object, see what's in there. In Express, it's a huge, huge object, but you can like go drilling down without having to add log statements for each one of these. Yeah, we can see what's in our headers. Fun stuff like that. And then we can step forward and find out what our product object is after we've executed get product. And just like that up here, yeah, there it is. Cool. So we've been able to just easily inspect the execution of this server. Hugely valuable. So just like that, our process has kind of become a lot easier. And crucially, we don't have to restart the server. That means that even if you didn't have any breakpoints, your editor just is already attached or isn't even attached, as long as the debug server is running in the first place, you can anytime add a breakpoint and attach your editor. You don't have to restart it at all. So in argument, it's kind of easier than Console.log. There's nothing to restart. You just add a breakpoint, hit F5. That's local debugger. We're going to look a little bit at production debugging. Now, production debugging is a bit of a different beast, right? We can't keep executing the same thing over and over. A user tries checking out once, it doesn't work. Maybe they send an email to support, but like we can't ask them, oh, can you do it like 5 more times as I add some log statements, right? Like it's a one-time thing. We have to capture all the information the one time. So production debugging is a lot about having the answers to the questions that you haven't thought to ask. Things that might be valuable, you should be gathering. And that's easy to say after I've said, we use Console.log too much, right? We need to gather everything, but also we need to make it easy to navigate. And that's kind of conflicting, right? Ideally, when things go wrong, we might expect this. We might hope we get this. A stack trace, hopefully a valuable stack trace, as Nicolo told us, with source maps in place so that we can easily navigate to the code that is causing issues. But what if it's in a try-catch? What if it gets swallowed? What if it points to some deeply nested library and we can't find like the actual source of the issue? Well, we would hope that with logging in place, we'd end up with something like this, kind of these narratives, stories about users who try to start a transaction and it kind of works, and they retry and it succeeds or it fails. Like each of these is a narrative. But in actuality, with high enough throughput, it actually looks like this, right? It's hard to keep track of which user did or didn't work. If we have a user emailing us about how they couldn't check out, we need to parse, pour through this and figure out what is the start and the end of one user's journey. So this is kind of difficult. There are ways around this, but we have to be super mindful when we are logging. And this is further made worse when we've got these in place, log levels. A lot of us use it, and they're kind of meant to change the granularity of a log. If you set a log as critical, that means like things are on fire. But what the heck is an info versus a debug? Like, I don't know. When is it a trace and not a debug? If it's an error, but it's not one we care about, is that still an error, or is that an info? Or like, I don't know. And then in production, people tend to turn off some log levels, which makes this infuriating, because when you know that a log might have caught something and might have given you the information, and you know it's just not there because it was the wrong log level, like, why do we have log levels in the first place, right? The purpose is to make production easier, but it simply makes it harder when we're solving problems. So we have to try to gather all of this information. All of this might be relevant in telling a narrative, but at the same time, we want to keep it easy in local development when we are reading through our logs. And that's difficult to do. I'm going to propose one solution, which isn't the right answer. It's maybe a right answer, and that is application tracing. This is a common practice in maybe other languages and is kind of still young in the JavaScript ecosystem, particularly, well, client side it's experimental, but the server side of application tracing is maturing. Let me talk about what it is. A lot of us haven't been exposed to it. So to touch on it, imagine we've got our timeline of the events that happen in production. When you make a log statement, it looks like this. It's a split-second moment. At that instant, a purchase was made. And we might add details to it. We might extrapolate and say, like, this user made that purchase and they bought this. But our kind of timeline is made up of these instants, not of like stories, not of narratives. And they're all isolated. And each one of these, maybe if you wanted to tell a story, you might say, well, the password reset started at this point and it ended at that point. And anything in between is just part of this narrative. And that drills deeper and deeper, right? Sending email is not an instant, but it's composed of these events where you had to render the template and connect to the server. We think of these as strings of events that are user events, but console logging is not well suited for that. These are all disparate, and it's hard to correlate them all. Now, instrumentation or application tracing kind of changes the model entirely so that any event has a start and an end. Sending an email is a span of time that we can keep adding details to. We don't have to have all the answers at the moment we're announcing it. And this is called a span. Every span is part of a hierarchy of spans that are happening within it or around it. So dispatching an email is a part of sending an email. And this dispatching an email has attributes. These are keys and values that, kind of like a database, can be indexed, and we can have the event of email from ECMA. We can receive an email from ECMA, and that is not only isolated to the dispatch event, but is part of send email, which is part of password reset. So they're all correlated. That's the idea, is that we're kind of building these narratives. We're weaving a tale of what the user has gone through. So that way, when eventually we say, I didn't receive an email. I was supposed to receive an email, and support hears that they're missing an email. They can search and find the event that kind of fell through. And they can find out that that happened in the password reset flow. They missed the email. And we can drill down and see exactly at what step of the password reset flow did the user miss the email. So that's kind of the gist of it. And I think this is best demonstrated with a live demo. So let's pray to the demo gods, and let's try to convert an application from using logs to application tracing. Woo. I have two monitors. This is a problem. Let me quickly swap us over to mirroring my monitor 1 sec. I hadn't thought of this. There we go. Cool. We good. So we have what is a Fastify server. It's kind of like Express. It's just another node server with an orders endpoint. This is a fairly complicated endpoint with a lot of nesting operations. So you can see we announce that we get orders. We get all of a user's. We get a particular user. We get their orders, and then we detail the orders by populating the orders like products and payments and shipments. It doesn't really matter the inner workings. What matters is that it's fairly complex, and there's a lot of like nested operations. So when we're executing this, let me run our server. We're going to run node watch inspect, and on index, and we're listening on port 3000. And now I can get orders from port 3000. And Sid, you've cursed me. I don't want my updates. So we've retrieved the users, we've retrieved the orders, but we haven't been able to correlate them all, right? In isolation, they're kind of just events in the ether. Now, I'd say the easiest takeaway from this is, if you haven't been doing it already, let's add unique identifiers for our events. So what you can do is import crypto. We can create a request ID, which is a random UUID, and we can just prefix our events with a request ID. Obviously, we can make this prettier, but the idea still stands that our events are now correlated, just like that. So if I run the get again, suddenly they're all prefixed with the same ID. Tremendously valuable. If you're going to take anything away, this is it. But we're doing more than that. We're going to start tracing. So let's get rid of these log statements. We don't need any of that. And what we're going to do is we're going to import this instrumentation file. And this is a file that kind of sets up OpenTelemetry. That's the library we're using for instrumentation. This is kind of the de facto standard. They maintain a standardized protocol, and this is used across languages. And there's not a whole lot else to know here. What's important, though, is that we're going to wrap this function in a span. So we're going to get our tracer from this instrumentation file, and we're going to start an active span. This wraps a particular event and basically says all of this is related. These are all like sibling events within it. And then we can go ahead and add to the span our attributes, our user ID, and span set attribute. I don't want the count. I want orders IDs. Yeah. And just like that, when I hit the endpoint, we didn't get anything is what happens. Did I save? I did save. Oh boy. Oh, yes. We have to return the tracer because it wraps around everything and kind of returns what executes. It worked. It's not logging. And it's not logging because it should be. In any case, let's try checking out my emergency things aren't working branch. Uh, so we should be seeing things in the log, but that's besides the point, because what I was going to say is that the logs are very helpful. It's going to kind of log out these large objects that are hard to parse through. And the truth of the fact is that we're not restricted to having to read through lines of logs. What we can do is instead look at a UI. So I'm going to run in Docker what is a UI for traces, and our logs are going to ingest there. So it can look a little bit like this. If I hit the endpoint and I open up my browser, and I'm sorry for the bright lights, this is Jaeger. Jaeger has a service here called live demo that it received traces for. And we can see here that we received a request to get orders. And just like that, inside of orders, we have this call to get user because I forgot to demonstrate that. I instrumented get user as well. I added this start active span, I set some attributes, and just like that, as a step in get orders, we now are able to have get user. It's a nested related event with its own tag, so we can now retrieve things like the user email and the user name. And from this, let's say we have 100 such events. I'm going to make a nice loop. While true, we're going to get our ports orders, and we're going to do this a lot. We're going to hit it a ton. But importantly, now if I find traces, we got a lot of them, I can say, let's find the trace where the user name is that one, Tabitha. And it pulls up the one event where it happened. And this is digging deep down and finding us all these related events instead of just like one log line in isolation somewhere. And we can find all the related events. So if I go ahead and I were to say instrument the entire application, which is what I've done here, and we remove this search, we can now start getting these full stories. Instead of having one span, say we got 52 spans. All these nested functions are themselves instrumented. So if I hop back to my code, I instrumented get products and get payment and get shipment with its own attributes and details. And just like that, we can open this up and kind of get a full story of what exactly is happening in our runtime. We can see that all of these events are trailing behind the process of getting the user and getting the order. And we have a beautiful waterfall, and we can see like maybe where we're spending most of our time or where we're unnecessarily awaiting an event. So this is kind of touching on the idea that Console.log is kind of the easiest tool for the job, but it's not the best tool for the job. This gives us so much introspection because we are able to truly understand the underlying flow of our code, and we can pull up a particular shipment by its shipping ID. So that's kind of the gist of it here. Going back here, I'd recommend all of you kind of check out OpenTelemetry if you haven't for production tracing. And what's amazing is that this isn't an all or nothing thing. You can start by adding tracing to your most, safety critical parts of your application, or the things that you're least confident in, the flaky parts of your Node app, say the checkout flow or some important jobs. And you can start having better detailed analysis of these parts of the application that are otherwise, just a jumbled mess or unreliable. That's kind of it for the humble console log. It doesn't have to start and end here. The big takeaways, I think, are harness your powerful tools. Our editors have gotten so good, and they have such powerful built-in debugging functionality and all sorts of other things that a lot of us aren't even using. Like, we've been programming the same way for 10 years, and we just keep doing it because that's what's comfortable. But it's not the best way to solve problems when they arise. That's not how we address production issues in a timely manner. Next, observability doesn't come free. You have to be thoughtful about the process of correlating whatever information you might get from a report all the way to the source of the issue or other correlated reports. So I highly recommend you think about the process of incident recovery when you're just starting to build out your application, because it's something you're going to regret not having done. And finally, think about the narrative. Try to preserve that narrative from the user's perspective. How do we correlate one particular user's experience to the potential source of issue? That's the gist of it. Thank you so much for listening. I hope you all enjoy the rest of the conference.